Assalamualaikum warahmatullahi ta'ala wabarakatuh. So today, me and my friends from Group 3 are going to present about our assignment 2, which is Clutch and Torque Converter. So, this is our group members. We have Afif Farhan, Afiq Zul Anas, Arif Haiman, and myself, Haris Daniel. Okay, so let's move on to the clutch history. So, first and foremost, the clutch was invented by a German mechanical engineer which is known as Carl Benz. Who is Carl Benz? Well, his last name is now recognizable across entire planet as Mercedes-Benz. Carl's clutch initially went into the first forays into combustion propelled machinery. However, there was a problem. The clutch would burn out rather quickly as the threads in the clutch covers were so precise and tiny that they burned out so fast. This would result in a slippage and the need for replacement in a short amount of time. Fortunately, replacing a clutch was something that a chauffeur could do easily and it was relatively inexpensive. So next is the history of the torque converter. So, like the majority of the inventions throughout histories, the torque converter arose out of a desire for convenience and efficiency. It became apparent to designers that internal combustion engines were not transferring the full amount of power produced into used energy. So the torque converter engine was only be controlled in a rudimentary fashion. So to solve this problem, the torque converter came into existence. They first enjoyed the widespread use in locomotive and strictly diesel units. However, as the advantages of the torque converter became apparent, it began to be installed in vehicles of all sorts of sizes and levels of complexity. Okay, so next, the function of clutch. There are two. So first of all, there are many types of clutch designs depending on the application. Most of the automotive clutches are a dry single plate clutch with two friction surface. And no matter the application, the function and the purpose of a clutch is to transmit torque from a rotating driving motor to a transmission. Clutches requires a mode of actuation in order to break the transmission of torque. The clutch pedal is a method of leverage to disengage drive from the engine to transmission from within the vehicle. Function of torque converter. The torque converter is what makes an automatic transmission in a car or trucks to move, and they're an integral part of an automatic engine. The torque converter is what transmits the torque from the engine to a rotating driven load. In an automatic transmission car, the torque converter connects the power source to the load.
Bismillahirrahmanirrahim. So next I'm going to present about the concept of clutch and torque converter. So first of all, I'm going to present about the concept of clutch. Clutch have three main parts, which is driving member, driven members, and operating members. So how does clutch work? So when the clutch is engaged, the power is transmitted from the engine to the driving wheels through transmission system and the vehicle starts moving. When the clutch is disengaged, the power is not transmitted to the rear or driving wheels and the vehicle stops while the engine is still running. The clutch is disengaged when starting the engine, when stopping the vehicle, when shifting the gears, and when idling the engine. And the clutch is engaged when the vehicle is to move and is kept engaged when the vehicle is moving. Clutch also allows the continuous taking up of the load. So next, I have marked few points of how working principle of clutch. So first of all, friction principle. Clutch operation is based on the principle of friction. When two friction faces come into contact and are pressed, they unite due to the generated friction. Second, dependence on friction factors. Friction intensity relies on the area of the surface, applied pressure, and the coefficient of friction of the materials involved. Surfaces can be intentionally separated or brought into contact as needed. So third one, driving and driven members. One surface acts as driving member while the other is the driven member. The driven member rotates continuously, and when the driven member contacts the driving member, it starts rotating and separation halts its rotation. Fourth, clutch engagement process. Friction surfaces are designed for the driven member to initially slip on the driven member when pressure is applied. Increasing pressure gradually brings the driven member to the speed of the driven member. So when the speed of the two members become equal, there is no slip. The two members are in firm contact, signifying full engagement of clutch. Okay, so the driver member of a clutch is the flywheel. The driver member is the pressure plate. So clutch plates are positioned between the two members. So clutch engagement transmit power from the engine to the rail wheels through the transmission system. Last one, disengagement process. Clutch disengagement occurs when the clutch pedal is pushed. So this action disconnect the engine from the transmission, stopping power flow to the rail wheels while the engine continues to run. So next, the concept of torque converter. So this is the torque converter. So working principle of torque converter, I've divided into 3 points. I've point out the first one is stall. When the engine is stopped, which is stall, the engine is giving power to the impeller, but the turbine can't rotate. This occurs when the car is still and the driver has the foot on the brake to keep it from moving. In this state, there's maximum increase in torque when the driver takes the foot off the brake and presses the accelerator. The impeller speed up, causing the turbine to move. Now, there's a significant speed difference between the impeller and turbine, with the impeller moving much faster than the turbine. Second one is acceleration. So during the acceleration, the turbine speed keeps on increasing, but still there is a large difference between the impeller and turbine speed. As the speed of the turbine increases, the torque multiplication reduces. During acceleration of the vehicle, the torque multiplication is less than that is achieved during a stall condition. So the last one is coupling. So the coupling is when the situation of the turbine achieves approximately 90% speed of the impeller, and at this point, it is called the coupling point. The torque multiplication ceases and becomes zero, and the torque converter behaves like a simple fluid coupling. At the coupling point, the lockup clutch comes into play and locks the turbine to the impeller of the converter. This puts the turbine and impeller to move at the same speed. The lockup clutch engages only when the coupling point is achieved. During coupling, the starter also start to rotate in the direction of the impeller and turbine rotation.
So I will continue with mechanical theory of clutch. So a clutch is a mechanical device that engage and disengage the transmission of power between the engine and the transmission system in a vehicle. It operates based on the principle of friction and pressure. When the clutch pedal is depressed, the plate releases the friction disc, disconnecting the engine from the transmissions. Conversely, releasing the pedal re-engage the clutch, allowing power transfer. The design involves consideration of friction materials, pressure plate mechanics, and release mechanism. Understanding the mechanics of clutches is essential for optimizing their performance, ensure smooth engagement, and managing wear and tear in various automotive applications. Next, we talk about the torque converter. The torque converter, a key component in automatic transmissions, operate of fluid dynamics principles. It comprises an impeller connected to the engine, a turbine linked to the transmission, and a stator for fluid flow redirection. Torque multiplication during acceleration is achieved by manipulating fluid dynamic between the impeller and turbines. A lookup clutch may mechanically connect them at higher speeds. Additional consideration involve centrifugal force, heat generation, and cavitation influencing design choices. Material and manufacturing process are crucial for ensuring durability and performance in varied applications. So I will pass the next slide to the upbeat.
Okay, next, I, Muhammad Fahad, would like to present about the difference between clutch and torque converter. So, before that, these are two different systems that used in automobile, but both of this system is used for the same purpose, which is both of the system is used to take the power and transmit it to the gearbox. So, what is different between clutch and torque converter? Firstly, we know that clutch is used in manual transmission vehicle, while torque converter used in automatic transmission vehicle. From that, there is some difference between clutch and torque converter. Firstly, the most obviously one is clutch is transmit the power by creating mechanical linkage with the engine to transmit the power, while torque converter hydraulically linkage to the engine and transmit the power by using the fluid inside the motor. So that's the first difference between clutch and torque converter. Next, there is also difference between clutch and torque converter, which is the main component that involved during the power transmit process. So firstly, for clutch, the main component that involved during the power transmit is clutch plate. So as I said just now, we know that clutch usually used in manual transmission vehicle. So there is operating member for the engine to transmit the power, which is the clutch or foot pedal. So from the clutch or foot pedal, we have to put some force to the pedal so that the power will mechanically linkage to the engine to transmit the power. So that is main component, which is the clutch plate to transmit the power. Next, as I said just now, for torque converter is usually used in automatic transmission. So for the automatic transmission vehicle, there is no clutch pedal because the gear is automatically changed. However, there is three main component of the torque converter, which is stator, impeller, and the turbine. So all of this component will automatically help or smooth the process of changing gear in the torque converter. So that's the difference between clutch and torque converter. However, lastly, I would like to present about different on pros of clutch and pros of torque converter, which is the pros for clutch is cost less than torque converters. For example, during the service or during the repairing, clutch more cheaper and more efficient during the service or repairing the clutch. For torque converter, the pros are easier to handle the system, and the torque converter deliver quieter and smoother performance. That's all for difference between clutch and torque converter.
Okay, so for my conclusion, I can conclude that both the clutch and the torque converter are essential for a vehicle to run smoothly without any damage. The equipment that is used in the engine of the car is very important to make sure that we can have our daily drive smoothly without any problems.
Okay, for conclusion, my opinion is both clutch and torque converter have its own function and have pros on operating to their related to their suitable work.
So, in conclusion, the clutch and torque converter are crucial in how cars can transfer power. The clutch in manual transmission smoothly connects and disconnects the engine and transmission through friction, ensuring a smooth ride. So, the torque converter in automatic transmission uses fluid dynamics to keep a constant link between the engine and transmission. This smart system works well during stop, providing necessary power for stationary vehicle. The clutch needs manual skill while the torque converter relies on automatic precision.
Next, in my conclusion is, in conclusion, clutch are provider for power transmission, relying on friction and pressure principle with design hierarchies influencing performance, while torque converters, vital in automatic transmissions, achieve torque multiplication through fluid dynamics, incorporating considerations like centrifugal force and heat, with material and precise manufacturing crucial for overall durability and performance in diverse applications. Next, this is the inference when we making the slide. So that's all from us. Thank you.